Nanotechnology in Solar Panels by Skylar, Zane, and Will. Here's the table of contents.
UN Goals of Sustainability. Our goal is goal number 7, access to affordable and clean energy.
Band gaps. The band gap represents the minimum energy that is required to excite an electron up to a state in the conduction band where it can participate in conduction. The band gap's function is to create a space for energy transfer, moving electrons from the valence band to the conduction band across the gap. A more efficient semiconductor or conductor can be used to close the band gap and allow for more efficient transfer of electrons across the gap. Photons from light energy excite the electrons in the valence band, allowing to have enough energy to jump across the conduction band and create an energy current.
Intermediate band solar cells. IBSCs are an already existing form of nanotechnology that act as a semiconductor. It shortens the band gap, making the jump of electrons more efficient and conserves more energy than the current usage of single gap solar cells.
Quantum dots and zinc oxide. A quantum dot is a type of IBSC which is made up of a nanomaterial called nanocrystallites. It acts as a semiconductor which closes the gap and allows for electrons to transfer more efficiently than current solar cells. Zinc oxide is the material that makes up nanocrystallites. It is non-harmful to humans and allows for more efficient transport of electrons than the current method.
Doped versus undoped zinc oxide. The figure on the left compares the energy levels of undoped zinc oxide and copper-doped zinc oxide. The figure on the right compares the energy levels of undoped zinc oxide and manganese-doped zinc oxide. These doped zinc oxide elements are much more efficient in closing the band gap than regular undoped zinc oxide.
Fusion of nanotechnology. Our first step would be the replacement of silicon. The current method of controlling the band gap is the use of silicon as a semiconductor for the electrons. However, this is not efficient at all. Our second step would be the implementation of IBSCs. This is a form of nanotechnology which is a more efficient method of closing the band gap than the current method using silicon. Our third step would be doping zinc oxide. Fusing zinc oxide with the transition metals copper and manganese through the chemical reaction of fusing the dopant to the crystal structure of the zinc oxide. Our fourth step would be quantum dots. Quantum dots harness the potential of the electron current in the quantum well of the band gap. Our final step would be the final fusion. The implementation of the dope-infused nanocrystallite zinc oxides making up the quantum dots into the band gap of the solar cell and energy grid will allow for a more efficient stream of electrons, making solar energy cheaper and more efficient while keeping it clean and good for the environment. Thank you for your time.